Here we have a diagram of a basic reflux setup. Some important things to note are, first of all, the height of the pad. The height of the pad is so that it is above the burner, so that the tip of the flame, when the burner is on, just reaches the pad. This ensures there's ample heating without excessive heating, so that you have a proper heat going to your sample. The round bottom flask is positioned just above the heating pad. This way heat can be transferred to the round bottom flask, but is spread out evenly, allowing for even boiling. If the flask is touching the pad, there would be a concentrated point of heat transfer, and so you'd have uneven boiling. In addition, if it is too far away from the pad, it will not have enough heat to cause boiling. The water flows in the bottom of the condenser so that it will fill the condenser up and then flows out the top. This way, the entirety of the condenser has water in it, so that the vapors can be condensed all the way up. So this system is used for reflux. Now, reflux is a technique used to carry out a reaction in which a solution is heated at the lowest boiling point of reagent's boiling point, so that it will evaporate. The vapors, however, so they're boiled in the round bottom flask, the vapors are condensed in the condenser and then drip and fall back down into solution. This allows a reaction to take place by heating without losing any of the solvent. So anything that is evaporated will simply just drip back down into solution. So up here, you'll note we have a loose clamp on the condenser. The reason we keep this loose is that it is only there to support the condenser so that it does not fall over. If tightened, the condenser may be held up and not seal properly here between the round bottom flask and the condenser. This would mean that some of the vapors could escape, and so we would be losing reagent, and so the reflux would not carry out properly. HBr is required for the reaction we carried out in the lab. However, we did not add any HBr as a reagent to our reaction. Instead, HBr was produced in situ by the reaction between sodium bromide and sulfuric acid, in which sulfuric acid donates a proton to the Br- ion, forming HBr, which then can take part in the reaction. HBr cannot be added safely in our lab, and so it was produced in situ as it was still needed. HBr is a dangerous gas if inhaled, and so to prevent inhalation of the HBr, we use this HBr trap. Now this trap, it contains aqueous hydroxide, such as sodium hydroxide solution. Now the gases from the reflux travel up the condenser, the HBr gases. They will not condense because they have a very low temperature at which they condense. We have a stopper here to prevent the HBr gases from going out of the vacuum takeoff, and so they all travel through this tube here. Is attached to the top of a 60-degree funnel, or the spout of the 60-degree funnel, which is inverted and then placed in the aqueous sodium hydroxide. You have to make sure that the bottom of it is entirely submerged. This way all the gases will flow to the sodium hydroxide, and they must pass through it in order to get out. What this means is, and then what occurs then, is that the HBr reacts with the hydroxide in solution, once again forming sodium bromide and then hydrogen gas. This makes sure that the gas produced is not released as HBr as it undergoes a reaction, and so it will not be inhaled. In addition, when taking the apparatus apart, we place it in a fume hood so that the vapors that were trapped left over in the condenser were not released, and so also were not inhaled.